Okay, this okay. Okay, this is a quick intro to one small category of ionic compounds where we have transition metals. Now, one of the tricks with the transition metals is we can't easily predict their number of valence electrons, and therefore we cannot easily predict what their charges will be in ionic compounds. They're metals, so they're definitely electron losers, but depending upon who they're combined with and the conditions, they can oftentimes form ions with different charges. So we've got to have a slightly different way of naming them. So for example, if I take iron and mix it with oxygen, I can actually get two compounds. If I use a little bit of oxygen, I get this compound with the formula FeO, one iron with one oxygen. On the other hand, I use more oxygen and I get this compound, Fe2O3. Now, what we've been taught so far is we would try to name both these compounds iron oxide, but that won't work because we have two different compounds with two different formulas. They have to have different names. So here's what we do. We look at the compounds and decide what the charge is on the iron ion. So for example, in this compound, we look at this and we know oxygen is going to be our reference compound, our reference ion. We know oxygen, when it forms ionic compounds, always has a charge of -2. Again, oxygen has 6 valence electrons. It's always going to be looking to pick up 2 electrons. No doubt about that. So it becomes a reference. Then we look at this and we say, well, gosh, we know that ionic compounds have to be neutral. Therefore, the iron is +2. Okay? So the iron in this particular compound is a +2 ion. And therefore, we call this compound iron. Okay, naming the metal, the cation first, and then we use the Roman numeral 2, where that Roman numeral 2 is referring to the fact that the iron has a +2 charge, and then we just finish up the name like we normally do, oxide, again, adding that IDE ending for a simple binary compound. So that compound is called iron 2 oxide. Let's look at the other one. In the other compound, again, oxygen becomes our reference, and again, oxide is going to have a -2 charge. Oxygen, again, 6 valence electrons, picks up 2 electrons to form a -2 anion, the oxide ion. But we've got 3 of those in our compound formula, and so 3 of those, 3 times the -2, gives me a -6. Okay? So the 3 oxides are contributing a total charge of -6. They're being balanced by 2 irons. I know the compounds have to be neutral, so I know those 2 irons have to be giving a +6 total charge, and therefore each iron must be, I bet you guessed it already, +3. Therefore, you can probably figure out this compound is going to be called iron Roman numeral 3, where the Roman numeral 3 refers to the charge on the iron oxide. Okay? So, just a little bit of a change. So whenever you see that Roman numeral, first of all, that Roman numeral is only ever going to be used with the transition metals because the transition metals, many of them, not all of them, but many of them have this special property that depending upon how and what they're reacting with, they can have multiple ionic states. Let's do another example. If chromium reacts, chromium will form these 2 compounds. Okay. Chromium CrNO3 2 and chromium NrO3 3. Let's see if we can name those. First of all, we see chromium and we see the nitrate ion, one of our polyatomic ions, and so these both are going to have chromium and nitrate, but we have to figure out the charge on the chromium ion. Over here, nitrate ion we know is -1. 2 -1s gives me a total anion charge of -2. Therefore, the chromium must be +2, balancing it out. Okay? So this compound is called chromium 2, Roman numeral 2, telling the charge on the chromium, nitrate. Again, we named the ion. This one, probably already figured it out, 3 nitrates, a -3 from the total charge from the 3 nitrates, has to be balanced by a +3 from the chromium, Therefore, this one is called chromium 3 nitrate. Okay, so that's going from the formula to the name. That requires probably the most work. You've got to take a pause and make sure that you are figuring out what the charge on the cation is. Somebody gives us a name. Cobalt 2 sulfide. Okay, cobalt 2 sulfide. Again, what does the Roman numeral 2 tell us? We want to get the formula. The Roman numeral 2 tells us the cobalt has a +2 charge. No way for us to be able to predict that, at least with our level of knowledge at this point, when we look at the periodic table. Okay, so that's why we need the Roman numeral. Cobalt is in the +2 state. Sulfide, look at the periodic table. S, sulfur, 6 valence electrons, is going to pick up 2 electrons. It's going to be a -2. So cobalt 2 sulfide is going to be a formula COS. You're probably not surprised. There is a cobalt 3 sulfide. Again, depending upon how we put those, how we do the reaction, temperature, quantities of cobalt and sulfur, okay, we can get a different compound. So there's a compound called a cobalt 3 sulfide. How are we going to figure this one out? Same as before. The 3 tells us the cobalt is in the +3 state. Sulfide is going to still be -2. It doesn't change. And now we've got that situation where I've got a +3 and a -2. The simplest way to put those together is to get 2 cobalts. That gives me a total charge of +6, combined with 3 sulfides to give me a total charge of -6. And there's my formula for cobalt 3 sulfide. All right, so that's a real quick introduction to the simple thing we have to add when we are naming certain transition metals. Okay, keep in mind that the Roman numeral is used to indicate the charge on the transition metal. All right.